In this one, we're going to talk about type annotations, also sometimes known as type hints. This is extra code that we can put in our program that does, well, nothing within the code. So why am I suggesting we write extra code for nothing from our program's perspective? Well, this code can be used by our IDE to stop us making stupid mistakes. And before we get started, I want to bring your attention to something we haven't really talked about before, but this green tick in the top right-hand side of PyCharm. This tells us that our code meets all standards and it can't find any issue with it. Let's talk about what this code's actually doing. Basically, we're passing a list of numbers to this running total thing and it will generate running totals. So if we run this, the result we get out is 1, 1, 2, 1, and that's because 2 and 1 is 3, and then 3 plus 3 is 6, 4 plus 6 is 10, and so on. Now, because it's a running total and we're summing stuff up, we have a bit of a problem here in that if I accidentally put in hello, you'll see the green tick is still there, which is telling us that our program is fine, but if we run it, it's going to crash. What we want to do in Python as much as possible is detect these problems while we're coding them. So how can we start to do that? Well, if we actually go to the package that generates this running total, and there are better ways of generating running totals using something like NumPy, but for this purpose, this is what I wrote to do it. And the way type annotations work is we can tell the system what type of variable we expect. So if we put a colon and then list, we've just added the type annotation of list to nums. And what this means is if we go back to our code now, you'll see we now have a yellow exclamation and this is now highlighted. And it's telling us it expected a list but got string instead. And you'll see the warning here is exactly the same. So we know now we've made a mistake. But this doesn't fix the entire problem because if I have a list of characters, this will also blow up. And you'll see it's gone back to a tick. Run it, blows up. What we need to do is tell it we want a list of integers. So to do that, we're going to go back into numerics and we are going to import from typing, import list. Now list here has a capital. And now we change this to list, and then in square brackets, we put the type of object in there, which is going to be an int. And we need to put an extra line in, or pep8 will whinge, and we've gone back to green. Go back to our main file now, it's gone yellow. And that is now telling us that it expects a list of integers, but got a list of strings instead. And this will say exactly the same. So we now know we've made a further mistake. If we go back to our original now, everything will clear, we know our code is good. We can also put things in our code to tell us what we expect. So I could pretend that results is actually an integer, which it isn't. It's a list of tuples. And we've now got an issue here because it's saying it expects an iterable because we're going to loop over it, but it got int instead. So this tells us here that there's a problem. We can also go to our code and tell the people calling it what you expect to get back. And the way we do that is do a dash, a greater than symbol, and then we are going to put here list of tuple. And if we go back to our main code, you can now see that this is erroring as well. And it says we expect a type of integer, but we actually got a list of tuples. So now we know that our code is wrong here. And we can either say list or list of tuples. And I'm not so worried about putting type hints in this code. It's more about the code I'm calling because that's going to make up our programs over time. They're going to get more complicated. They're going to be harder to work with. Now, if this file becomes many thousands of lines long, then yes, type annotations all the way. But for now, not too fussed here, very fussed here. So this is basically saying numbers is a list of integers and this function returns a list of tuples. Within here, to be even safer, we can give our expectations and it's the same way we would do in parameters. So it's lrun nums and that is going to be a list of integers and retval is going to be a list of tuples. And you see all this code is still green. So that is how type annotations work. You can use them in line with variables just by putting a colon after the variable and then the type and then equals, or within parameters in exactly the same way. If we had a default parameter here, we'd just put equals again. And then for return, it's dash greater than and then the data type, and then the colon to end the function definition line. And our code is now still green and everything's amazing. So this helps us get around one of the big problems with Python being a dynamically typed language, which is you can make lots of errors by inadvertently changing the data type of what you're working with. We can still run this, it's still going to error, but we're learning far earlier in the code what the problem is, not having our runtime tell us. I hope you found this useful. If you have, then please leave a like and possibly subscribe. And with that, thank you for watching, and I hope to catch you on the next one.